Namaskaram, everyone. Today, we will talk about project management for actuaries. Why do actuaries typically require to understand project management? And from their perspective, what actually is project management? So, the first module that we will talk about is the basic foundations of project management in actuarial work. So, if I really look at the actuarial projects, what are the characteristics? What are the risk related elements? If we have to understand that, the actuarial projects typically they involve quantitative modeling. They require financial evaluation to be performed, and also some amount of risk assessment has to be done. Three broad areas. Quantitative modeling is required. Financial evaluation is an important component. And throughout the process, risk assessment. So whether you are talking about insurance pricing model or reserving model, right? Or probably the pension liabilities related valuation, the risk capital related modeling, product profitability analysis, any of the projects that we take up, they all involve these three dimensions. So, if I have to understand the kind of common characteristics associated with each of these projects, there is a heavy reliance on the quality of the data because the the garbage input will always lead to garbage output only. So how good is the quality of data? And all these projects typically get a good understanding of statistical models as well. So there is a heavy reliance on the quality of data, heavy reliance on statistical models, and you make lot many assumptions. So which means based if your assumptions are changing, the overall results might drastically change. So the sensitivity to the assumptions is very important to understand. And because some of these projects are pretty long term kind of projects, even the implication, the financial implications in the long term also needs to be understood. And along with all those things, they are also very closely scrutinized or monitored by the regulators as well. And when I look at the broad risks that can exist in typical actuarial projects, one major risk is a model risk. You might not specify the model correctly. The overall structure of the model itself could be erroneous. You might be using incorrect methodology to arrive at the computations, calculations, etc. And because of that, you might land into wrong outputs, erroneous outputs, because you did not design your model structure appropriately. The second level of risk the second kind of risk that you might look at is the data risk, where a lot of data that you work on may be either incomplete or maybe biased, or it could be inaccurate. So any of these kind of erroneous data might very well land into erroneous kind of outputs as such. Then there could be assumption. We all make so many assumptions regarding the mortality, morbid interest rates, inflation, lot of stuff, right? And based on that, there could be a kind of a risk associated with the assumption, mortality related assumptions, interest rate related assumptions, the lapse rate related assumptions, etc., etc. And finally, you can also talk about an implementation risk, which is more like the deployment. We have some problems when we are deploying this model or with the spreadsheet modeling. So, if you look at most of these actuarial projects, they play a very, very important role in a major financial decisions. And because of that, the project management becomes a very, very crucial aspect. Understanding the projects in more detail, understanding the whole flow of the project, the various stages involved in a successful project will make it even more important for them to understand. Now, this is where now I will bring in the dual role of the actuary. We all appreciate the actuary is always a technical specialist, is a very solid technical specialist. But I also see actuary as a good project manager as well. Right? You should perform both the roles. As a technical analyst, yes, you develop models, you do a financial evaluations, you validate the various assumptions, you look at the sensitivity analysis, you interpret the results that come out of the assumption, that come out of your models, etc. So you are definitely a technical specialist as an actuary. However, some of the tasks that are expected is you have to coordinate various analytical tasks. You have to manage the timelines and deliverables, right? You should stick to your timings. You should have a proper scheduling in place when you are going to complete what. So that is what is the managing timelines and deliverables. You should work with your resources, whether it is human resources, software resources. You should be able to allocate the resources more and more appropriately. And you should also have a kind of a comfort in terms of communicating the outcomes of your model, which is a technical outcome that you might get, more to a non-technical kind of audience as well. So, which means these are some of the tasks which are actually expected for any project manager. And I would see that actually also should get a comfort in handling these kind of activities. Some of the regular responsibilities, if you see, model transparency is very, very important, right? Which means how well I communicate the model outcome, how well I understand the requirements of the model in much more non-technical kind of a parlance. To what extent the whole documentation regarding the model is adequate so that it can be explained to a non-technical audience quite comfortably. And at the same time, the actuary should be comfortable in terms of managing the uncertainty as well as the limitations of the model, etc., etc. Which means overall, an actuary is expected to balance between the technical depth as well as the project oversight. So there has to be a proper balance between technical depth and the project oversight. So this is what is expected in the role of actuary as a project manager as well as a technical specialist. Now, the next element comes in terms of how do I define the project related objectives? Primarily looking at in the actuarial context or financial context, what do I mean by defining the objectives of the project? So it's nothing but what is the decision the analysis is intended to support? What decision should come out as my output? Is it a pricing related project? So a pricing should come out wherein I should understand whether the premium that I am going to derive or compute, will it be adequate to cover the expected claims, expected expenses or not? That is a decision that I have to make. Similarly, if I am getting into a capital related decision, right? Solvency capital requirements, I should be able to estimate and understand whether the adequacy of the capital exists or not. Similarly, I can get into a risk management kind of a task or a project where I would like to evaluate what is the volatility, what is the financial volatility that is possible. And similarly, I could also look at from a profitability kind of a perspective where I can assess the product profitability over time. Now, these are the different types of objectives, and you could see all these objectives, they are clearly measurable, right? What is that I want to do? Did I do it or not? I can easily measure it. And they should be very clearly aligned with the business decision needs, right? The decision is to do a proper pricing. The decision is to do a proper capital adequacy assessment. The decision is to do a robust risk management. So, from that perspective, all the objectives are properly aligned with the business decision needs. And you should also see that these projects are achievable with the available data, with the available resources that I am having. So this is where defining the project objectives very clearly, which will ensure that you are selecting the right model, right? Unless your objective is clear, you don't know what model would be more appropriate. So, I mean, you should always spend time in terms of understanding the objectives of the project more comfortably so that you can plan your model selection. You can also plan properly what data would be collected for achieving this kind of an objective, and even the interpretation that you are making regarding the result is well aligned with the objectives itself. So that's the reason understanding the objectives becomes a very, very crucial dimension as such. And poorly defined objectives, obviously, it can lead to misaligned analysis and irrelevant outputs as such. That is where defining objectives becomes a very important task. Once I have defined my objective, then the next important thing for me is getting into a project scoping. What is there, what is not there. So, boundaries of the project. What is included and what is excluded as a part of this particular project. What is included and what is excluded. Right. So, that is what is scoping the project. You should clearly determine the boundaries of the model, which means what will the model do, what will the model does not do. What is the data that will be used, right? What is the cutoff date for which this particular model will be used? What is the time horizon for projection? Will I be projecting for the next 1 month, 1 year, 5 years, 10 years? What is the time horizon for which I would be doing the projection? And how am I evaluating the project in terms of the financial metrics? So, all those things will come under a proper scoping of the project as such. So, your pricing related project, you can do a scoping, or frequency and severity modeling that you are doing, you will have to set a scope for that kind of a project. So every project that you do, you are setting the scope for it. Scope is nothing but broadly what is included, what is excluded from this particular project, right? So in some cases you may include some of the things, and you may exclusively want to exclude some of the aspects as such. Now, you don't want, by setting that kind of a boundaries, by setting that kind of a scoping, you will prevent the scope creep, which means no new requirement will come in after you started working on the project, right? That is what is like a scope creep. No requirements are coming in at regular intervals, and you are not able to complete your initially looked at kind of a project at all. So that is where the scope creep has to be handled for a successful completion of a project. Additional tasks are added without adjusting the time or the resources. That is where it may look like you have you have overrun in the project, cost overrun, all these things very much possible. And obviously the whole scoping also should be documented. In the earlier case, we talked about defining the objective, which is very, very essential. Now the second important thing that we are doing is defining the scope of the project, which is also equally important. And then identify all the key stakeholders in the project and what are their needs, because you see that most of the projects, they will involve multiple stakeholders. The expectations of each of these stakeholders is entirely different. For example, let's look at senior management, right? For them, their expectation is whatever the project that you are doing, it should help them in terms of giving insights in such a way that they can take very good strategic decision. They should be able to project their profitability for the next couple of years as such. And they also look forward for the various indicators of the risk exposure. So some of these areas the senior management may be very much interested in. These are some of the expectations of the senior management. But on the other side, you look at another stakeholder like a regulator. They always want to see every project that the actuary has taken up, is it complying with the solvency related rules or not? Is the methodology transparent enough or not? Is the documentation done appropriately or not? Is the work replicable enough or not? Are all the assumptions properly documented or not? These are some of the dimensions that regulators are more interested in looking at. Similarly, when you think from the perspective of product managers, they want to understand whether this product is competitive with respect to the competitors, right? So whether this opportunity, whether this particular product can compete with the competitors or not, right? If I increase the price or decrease the price, what are the implications? So that is what a product manager is more interested in understanding from a project. Similarly, a risk management team, they want to get a decent understanding of the risk exposures across different products, across different lines of business, etc. They want to look at stress testing. What is the outcome that comes out of the stress testing? Capital implementation, things like that. On the other side, look at the IT team, the analytics team. They are more and more concerned. They are more and more bothered about, okay, what should I do to implement this model? What are the requirements for me to implement this model? How can I integrate this model into my enterprise system altogether? What could be the constraints in terms of proper integration? Now, you could see different actuarial stakeholders. So, how well you communicate, right? It could be in terms of either simplifying all the mathematical and the technical results, understanding the financial implications and presenting those financial implications, looking at uncertainty, limitations, etc., etc. That is where different types of stakeholders come into the actuarial project with different expectations as such. So these are some of the basic foundations of project management. Before we move to our next module, let's try to understand some quick conceptual check kind of questions relating to the same topic. An actuarial pricing project fails because the team later realizes the analysis of excluded distribution expenses that significantly affect the product profitability, right? Which project management issue primarily caused this failure?
Uh, the scope definition.
They did not define their scope properly, right? And because of that, it typically impacted them very badly. Fair enough. During an actuarial solvency modeling project, the actuary must explain complex stochastic simulation results to senior management who are not technically trained. Which role of actuary is more critical in this situation?
He should be a communicator of risk insights.
Fair enough. It's a communicator of risk insights as such. Good. Now, we will go into a couple of steps which would highlight a lot on the overall project life cycle, right from initiating a project to closing a project. This is what we are calling as the project life cycle. So any actuarial project, this in fact can work for any kind of project, not necessarily an actuarial project alone. This is applicable to any type of project as well, right from initiation to closure. Because unless I have a very structured life cycle, I cannot maintain the analytical rigor, or I cannot bring in a relevant decision into the implementation as such. So, if you look at the phases, broadly, I talk about initiation phase, then we move to the planning phase, then it is the execution, monitoring, closure. Now, the terms could be slightly different, right, depending on the resource that you are using, but broadly, their meaning will not differ. So, as a part of the initiation stage, we are identifying the business problem, or it could be a regulator related requirement that you have to implement in your organization, right? Yeah, whenever regulator comes up with some kind of a decision, The same has to be implemented in as a project within the organization, right? You should define, so all those things that we have already discussed, defining the project objective, project scope, what are the outputs that are expected from the project, right? Is it really feasible to take up the project? Do I have the sufficient data to execute this project or not? Is the project feasible? Do I have proper modeling expertise, modeling capability in my team who can quite comfortably execute this project? All those things you decide during the initiation phase. So it looks like you are taking up this project, right? And you have identified what data to use, what model to use. You have people who can build the model. So, which means you are ready to move to the next stage, which is the planning phase. And in the planning phase, you clearly think through what kind of models that you should use as a part of this project. More detailedly go into the scoping of the project, what is included, what is excluded, what are the assumptions that you would be going ahead with this particular project, and based on that you also plan the timelines, the resources. All that planning will typically happen during the planning stage. So once you are done with that, the execution is actual work. You collect the data, you clean the data, you develop the model, you calibrate the model, do a scenario testing, sensitivity analysis. All that is about the implementation of the model. And then you get into the monitoring stage where we validate all the intermediate results, see whether they are in line with the expectations or not. Then you review what assumptions, whether they are realistic or not. What if I change the assumptions? How would they impact the output? Look at the progress of the project against whatever the schedules or timelines that you have defined. And the final phase is about closure, where you would document all the activities that you have done. The model gets properly documented. The communication of all the results of the model are clearly done to non-technical audience, which could be your senior leaders or any stakeholder for that matter. Then you will also have proper plan with respect to what do you do with the data, how do you archive the data, and even if some kind of audits happen in future, you should have a proper backup plan associated with all that. That is what is about the project life cycle, starting from initiation to the closure of the product. And one technical word which we talk about in this context is the work breakdown structure. So this is what is your total project. It is dividing into small manageable component. The whole project will be broken down into a set of very small manageable kind of components as such. The major purpose is for each of them you can very well assign who will be responsible for executing this part of the project, how much time will they take to execute this project, what kind of resources are required to execute this project. So that is what a work breakdown structure. It typically starts off the stages. This is a data preparation stage, data extraction stage, the cleaning stage, the validation stage, the exposure calculations kind of stage. Like that, you can divide the overall project into different phases or stages as such. Now, when you really go into each of these stage, you will see that there are different tasks. Probably when you are designing the model, you will try to understand what statistical model do I use, what are the assumptions of my data as well as of my model. When you go into development, you are trying to understand what is the parameter estimation mechanisms that you would be doing, right? What kind of simulation we may have to do on the data, model architectures, all those things will come under the model development. Model scenario analysis, simulations, looking at how the model will react under different scenarios. All those is about the model development. Then you have validation, verifying what if I would have run this model on the historical data, what kind of outcome I'm going to get. Is this outcome well aligned with the broader level outcomes expected for a project? Then you will also end up preparing some technical reports, stakeholder presentations as a part of the reporting of the documentation. As a part of validation, apart from the back testing, you would also be looking at sensitivity analysis, which is more like if one variable changes drastically, what could be the impact on the overall output. You would also might want to look at a peer review. Now, this entire work breakdown structure is nothing but you are taking your mega project, breaking it into chunks so that you will be able to track it and improvise it much better. Then the next aspect comes in terms of the sequencing of the task, right? Because most of the times we need that the tasks are performed in a specific logical order. Because most of the times what happens is the outputs of the step 1 will become the inputs of the step 2. The outputs of step 2 might become the inputs of step 3, which means there could be a lot of task related dependencies that can exist, right? And from that perspective, let's say you work with data validation. The data validation will in turn lead to model calibration, which should again lead to scenario testing and then to interpreting the result. If the overall data preparation is incomplete, then the overall modeling itself cannot start. That itself is a major dependency. The dependencies can be either sequential in nature or parallel. Sequential is one task should be completed before the next task actually gets started. Parallel dependency is where both the tasks can run parallelly as well, right? For example, I can clean the data, and along with that, I can also read through the literature very parallelly as such. So, when I'm trying to understand the sequencing of the task, the dependencies between the different stages, if there are any bottlenecks in the entire process, we'll be able to identify those bottlenecks and work on those bottlenecks as such. And I can also look at the tasks that determine the duration of the entire project as such. You can use different visual tools like network diagrams, flow charts, etc., etc. Now, that is also one more important area which actually should understand as far as the project management is typically concerned. Then, the resource planning is another important activity. right? It's just not analytical skills that I require. I need many more resources. Probably I look at them as a data resource. Historical claims data is what I should collect from the appropriate sources. The different exposure related data, the policy related data, etc., needs to be very thoroughly captured. And even the other economic indicators, the GDP, etc., also should be the kind of data that. So I need to really look at the what are all the sources from which I can get the data, what kind of data is possible, what is the quality of the data, because that quality of data is what will impact the overall accuracy of the model as well. Then I also need to plan for the model related resources as well. It could be in terms of statistical models, simulation related aspects, the assumptions for actuarial model building, etc., etc., which means the the selection of the model, again, how complex the risk is and what kind of data is typically available. Then you should also plan in terms of your technology related resources, whether it is the actuarial softwares that you would prefer to use, any computing tools that you want to use, the overall infrastructure relating to the databases, etc. And all these technology related constraints may affect the sophistication of the model. And last but not the least, you also need to plan the human expertise related planning as well, whether it is in terms of getting the right number of actuaries, spread their areas of specializations, data scientists, domain experts, IT specialists. You need to get people with all these kind of background, right? So that is about the resource planning, which is again a very important aspect when you are going for an actuarial project. And time, right? One is you understood the work breakdown. You also understood in terms of the resources that are needed for the project. Now you can also go in terms of scheduling. What is the timeline for completing the project? Now, here three major things is what we discussed. One is a milestone, the other one is a critical path, the other one are the deliverables. Milestones, they are nothing but checkpoints. Until here, I completed my task. Or the task until here is still pending. It may take 2 more days. So it's a kind of a checkpoint for you to really understand whether the particular task has been completed or not. You can think in terms of data preparation, model calibration, validation results, things of that sort. So basically, the milestone is primarily for monitoring the progress of the project as such. Now, the critical path is a very, very important and interesting variable, right? So it is the sequence of tasks that determine the minimum project completion time. How many hours, how many days it will typically take for completing the project on time. That is where the critical path comes into picture. If any particular task is on the critical path, and if that particular activity is delayed, it will delay the overall project. For example, if there are 10 tasks, and let's say and let's say The task 1359, they are on the critical path, right? If any of these tasks are delayed, you should always try to ensure that you don't delay these tasks. It's not that you want to delay the other task, but in the other task, you still have some level of flexibility. Whereas in this task, you may not have, in these tasks, you may not have that kind of a flexibility. It is very much because if these tasks are delayed, it can very well impact your overall timeline of the project as well. And to identify which stages are there in the critical path and probably which steps are not present in the critical path, you should try to look at the various tasks that require close monitoring, and there is no scheduling flexibility as such. And managing the critical path essential in projects with regulatory deadlines. This is also another important point. And when it comes to the deliverables, concrete outputs produced during the project. So you might want to arrive at validated actuarial model where you have looked at the risk assessment of the project and you have typically provided the valued and validated actuarial models, risk analysis report, things like that. Okay. So, which means the more and more properly you are scheduling, overall the actuarial projects may remain more and more timely, more and more transparent, bringing in a lot more accountability into the process as such. So, let's quickly look at some conceptual checkers before we move on to the next part. During an actuarial pricing project, model calibration cannot begin until historical claims data has been claimed. So there is a prerequisite, and only when that prerequisite is completed, then only the next step can typically happen and validated. Which type of relationship exists between these two tasks?
Uh, so sequential dependency. I should go in a
Very good.
sequence.
There is a very good. It's a sequential dependency that becomes more important because one after the other is typically setting in. Only when one is completed, the other may have to be looked at. All right. Then, in a reserving model development project, the task final model validation and regulatory report submission lie on the project's critical path. Okay, we just now talked about what is critical path. If validation is delayed by 2 weeks, what is the likely consequence?
Project completion date delayed.
So anything that is there on the critical path, it means that you cannot delay it. If you delay that particular activity, the overall project timelines also will get delayed. And because of that, there will be a schedule overrun that can happen. You don't have that flexibility, you don't have that comfort of delaying a project that is there on the critical path. Fair enough. Now let's move on to our next topic. The next topic that I'm going to look at is quantitative monitoring and control. So this is all about progress of the project. How am I measuring the project progress? Right. So, which means you need to first understand what are the indicators of the project, the progress of the project, and you are monitoring those indicators as such. We have already talked about milestones, right? You will have to monitor those milestones because milestones are nothing but in the overall project timeline. You will put some specific time points where you will decide, am I able to complete my project till that particular stage by that particular time? They represent completion of the major analytical stages. That is what are the milestones. So, did I complete data validation stage or by so and so date? Or am I still in the process of completion? Right? Or did I complete the model calibration stage? Or did I complete the review of the result stage? So these are the major stages in any project, and we are trying to identify to what extent we are closer to completion of each of these stages as such. And obviously, deliverables also is something that you will measure because you know some tangible outputs are produced at each stage. At some of the things you may very well say, yeah, I am coming up with a cleaned data set. So did I complete it or not? I can easily track. The model that is calibrated, actuarial report. So I can very well look at the outcome and then see whether I have accomplished this or not. Then I also have metrics with respect to performance. How many tasks are completed? What is the proportion of tasks that are completed? How much of them are work in progress? How much of them are completed in time? Right? How many of them are delayed by how many days? All this is going to be a part of performance metric. And what you see is almost all the tools that you may work with as a part of project progress evaluation, they may want to understand what is that you have planned and what is it that is actually existing. So you planned model calibration to be completed by week 4, but actually it took week 6 to complete that particular project, which means there is a deviation from what was planned when it comes to the schedule. That is what is about the quantitative monitoring. And you could also look at budgeting and cost estimation because you have different resources who are involved that are involved, whether it is monetary resources or people related resources, etc. So obviously, all these resources are going to cost, right? So it could be human resource costs in terms of the actuaries, the analysts, the project managers, etc. The technology costs can come in terms of licenses, infrastructure, cloud processing related resources, etc. Getting some additional data sets, data acquisition related issues typically. The cost estimation requires forecasting project effort as well as the duration. Okay. So typical calculation is nothing but the overall project cost is nothing but what are the resources cost multiplied by what is the time required for execution of this particular project. And this is what is about the budgeting and cost estimating. Because if you are looking at very long term analytical projects, right? So obviously, even the people related expenses could be much higher. Technology Usage related expenses, etc., also would be much, much higher for them. Then the other quantitative monitoring element is in terms of risk identification, right? So, three major risks. One is the model risk, we talked about it. I created a model, I used it on my data. The model is wrongly calculated, and I see that I am getting I'm getting incorrect kind of results as such. I'm using a very inappropriate statistical model or a mathematical calculation or a formulation, or I might have done some kind of mistakes in coding. All of them are typically impacting, right? And probably when the relationship between the variables is not linear, let's say I'm using linear regression. This is like a wrong model that I have used, and that is what could very much lead to model risk. Data risk, poor quality data, incomplete data, inconsistency in the definition across the different data sets, right? And probably this kind of a missed data can have again different implications as such. So it's very, very essential that before you do any kind of modeling activity, you have to ensure that the data is proper and valid. Then you also encounter into assumption related risk as such, because most of the models that you are building, they are very, very much relying on the assumptions itself, whether it is the mortality rate assumption, interest rate related assumption, inflation related assumptions, etc. Right? If the assumptions differ from reality, then the financial projections also become more and more inaccurate. Then, once you have identified the risk properly, you should also have some kind of risk mitigation, right? So, once you have identified the risk properly, probably mitigation strategies are also very much required. How do you reduce? So, any risk is about the probability of that particular risk, and we also talk about the impact of that particular risk. Probability of that risk as well as the impact of that risk. So you would want to look at it as reducing the probability. When you are doing proper risk mitigation, you would either reduce the probability or the impact or both of them. So now, normally, what are those mitigation approaches that any company can typically plan? The typical mitigation approach is you can do a model validation rather than getting into a model risk. Probably whatever the model you have created, you get it validated. You do an independent review of the model design. You test the model, the outputs that come out of the model, you test them as against the historical data as such, right? And the next thing we talk about is the data verification. Rather than landing into data risk, you do consistency checks, you see if there are any outliers in the data, right? You get into a reconciliation with the external sources. So you may want to do a kind of data verification as such. And then when it comes into scenario testing, you want to evaluate rather than trying to see that your model fails under some condition. You may want to evaluate the model under different economic conditions. You may want to do a stress testing under the extreme outcomes, etc. And finally, even the documentation. You want to clearly understand what are the various assumptions, methodologies, what are the provide a detailed explanation for the same. So this is what is about the risk mitigation related strategies. You may want to get into those strategies as well. Then, even we talk about quality control when it comes to the actual deliverables, the actuarial deliverables. What is the quality control? Basically, nothing but whatever the output that you are bringing in, the output should be accurate, it should be transparent, it should be reproducible, etc. For example, right, you may want to do an independent model validation, looking into the verification of the model logic, replicating the calculations, etc., etc. You may want to get into back testing by comparing the model predictions with the historical outcomes. See how when any input values, which are your assumptions, if they are changed, what kind of impact they are having on the overall output of the model. You may want to get into a code review. These are all the different elements of providing quality control. You can do a better documentation by following proper documentation standards as well, where you do a model description, understand the data sources, assumption related justifications, etc., etc. Right? If you don't, more and more a proper quality assurance definitely will look out for. If at all you are able to bring in better quality control or quality assurance, your financial misstatements will not occur. Regulatory penalties can be avoided. All these typically are bound to occur. All right. So we'll look at some of these what you call the typical concept checkers associated with quantitative monitoring and control. During an actuarial reserving project, the team discovers that several claim records are missing from the historical data set. Which type of project risk does this primarily represent?
Sir, data risk.
Data is missing, so this is typically a risk with respect to the availability of the data. Fair enough. An actuarial team tests their pricing model by applying it to historical claim data to check whether predicted losses match observed outcomes. Which quality control method is being used?
Backtesting.
You are using the test your model on the historical data. So this kind of a mechanism that you are using is typical backtesting kind of a model. Fair enough. Now, this we will typically understand the governance, the communication, and implementation aspects relating to your projects. First thing I have already talked about is the documentation. Any actuarial project you take up, That work should be clearly documented. One is transparency. If someone wants to understand what you have done, it should be very clear for them. Then, if an audit has to happen on the entire process, you have sufficient information for that. And even the regulatory compliance is very much possible, right? And when you look at the typical elements in documentation, is about a clear description of the model. What is the structure of it? What are the key variables involved in the model, the inputs, the outputs? What are the relationships between the different variables as a part of the model? Then documentation of the data. What are the different types of data you are using in the model? What are the sources of that data? What kind of data cleaning activity you have done? What are the limitations of this data? All those should go as a part of the data related documentation. Then the assumption. What are the different assumptions you have used as a part of your model? It could be a mortality related assumption, the frequency of the claims related assumption, the interest rate related assumptions, or any other related assumptions as such. And also your complete methodology. What kind of statistical techniques you have used, what kind of estimated mechanisms you have used, etc. The moment you do a proper documentation, your operational risk is drastically reduced. Right? So that is what is one of the essential requirement, documentation, and a standardized kind of a documentation for any actuarial project work. Then the other important element which is expected from everyone is how well I communicate the technical results to the non-technical stakeholders, because most of the times you work in any actuarial analysis, you will be dealing with very complex statistical models, very complex financial models, but the managers here, right, are the leads of the various divisions. They need not be technical people, they need not be actuaries, so they may not have the required test related expertise as such, right? They may not typically have that kind of an expertise at all. Now, from that perspective, we should be in a position to translate the actuary must have the comfort in terms of translating all these quantitative results into very clear decision related insights as such. Okay. And so, which means you should focus more on the implications of this decision rather than getting into, you should focus on the implications of this decision rather than getting into the technical details as such. Right. And that is where you will try to understand the impact of the various results of your model, what is your risk exposure, things like that. You have to use as simplified explanation as possible in terms of explaining what is the probability of a loss event, what is the expected financial outcome, what is the worst case scenario. Instead of looking at presenting all the complex model equations, formulas, etc., you should choose a kind of a communication mechanism that could go well even with a lot of non-technical kind of audience as such. Then I would also have to talk about the governance framework. because from an actuarial perspective, models are very, very crucial stuff. So you should have a proper process in place to ensure that your models are very reliable, very much controlled. They are very, very much compliant with the regulations as such, right? Which means you are clearly talking about the ownership of the model, who is responsible. You are also trying to understand, or as a part of the governance framework, you should clearly come out with a very consistent modeling related procedures. Independent review is a very integral component of a good governance framework. Your model needs to be validated by an expert or a separate team altogether. And a formal approval is very, very much needed for every model before you go ahead using the model. And any changes you make to the model, any updates you make to the model, the version controlling has to be more and more appropriate. All this is a part of a stringent governance framework, and the proper governance framework you have, it would definitely address controlling the model risk as such, right? Because regulators, they would very much be interested in validating the model. Probably they would like to look at some of your records and documentation, which will say that you have done model validation, and you have to display to them some of the evidences or some of the results that come out of the model validation. Similarly, the justification of the different assumptions that you are taking as a part of the model, and the completeness of the documentation as well. So this entire thing goes as a part of the governance framework. And there is also a possibility of implementation risk. Most of the well-designed actuarial models, even they can very well get into lot many challenges when you are implementing, right? Because implementation is nothing but you are transferring your analytical models into actual operational kind of a system. And which means there could be coding errors, there could be a data integration problems between the different databases as well as your modeling system. Model formulas that you have created, they don't get properly translated into the software system. And because of all these things, like the formulas that you are using in the Excel sheets or the code that you are writing in Python, etc., they are not, they are erroneous, and because of that, the implementation in the production system is giving you wrong results altogether. All these can very well result in incorrect pricing, inaccurate reserves, and which can also lead to much operational losses as such. So before they get into final implementation, or at that point, you should, it's always advised that you go into proper system testing, independent verification. Don't do deployment all at a time. Go in a staged manner so that you can really understand where exactly the gap has typically occurred. So that is about the implementation risk. And the final stage in the project is about post project review. What are the lessons that you have learned? This is also a very, very important aspect. You will be assessing what is the performance of the project. You will identify what are the strengths and weaknesses of this particular project, right? So you will look at what what are the projections you have done, how good are those projections, how good are the assumptions that you have used, right? The project timelines. How to what extent were you able to meet the timelines? To what extent, what is the performance assessment of the various resources that are used in the project? The resource allocation related analysis is what you will try to do. How good was the communication with the different stakeholders? How effective was that communication? What were the issues that were unexpected and but they were encountered when we are doing the modeling, when we were doing the implementation? So a compilation of these kind of lessons learned while implementing the project would be very, very helpful as such, right? You can very well improvise for the next stage. Okay, you may want to come out with a proper better data validation procedure. You may want to improve the documentation process standards. You may want to define the scope of the project more and more appropriately so that the scope creep does not come up, etc. All these are very essential elements relating to governance, communication, and implementation of the project. Okay, before we wind up this particular session altogether, let's look at some of the important concept checkers associated with governance, communication, and implementation. An insurance company requires that every actuarial pricing model must undergo independent validation before being used for business decisions. Which objective does this requirement primarily support?
Sir, model governance and risk control.
Model governance and risk control. An actuarial model developed for reserving products correct results, reserving produces correct results during testing, but generate incorrect outputs when integrated into the company's IT system due to coding errors. This situation represents which type of risk?
It is an implementation risk.
Okay. So, with this, we come to the close of this particular topic. I will stop this session for today here, and probably on Monday we'll again go ahead with our next topic as such. Okay, so thank you very much, and I would also
Thank you, sir.
upload the slides, etc. So thank you very much. We'll again meet up on Monday. Thank you. Bye.
Thank you so much, sir. Yes.